Hello, it's Dr. Mears, and today we are going to be going over SAT Strategy Session 2. This is about ratios and proportions, so let's dive in. The ratio of cats to dogs at a local kennel is 3 to 8. If there are a total of 77 cats and dogs at the kennel, how many more cats would make the ratio of cats to dogs 1 to 2? There is a lot to unpack here, so I did it step by step. So let's take a look at how I did it here. Okay, so first I wrote down how many cats and how many dogs I have, and so the total number of animals that I have right now. And so the total is 8. 3 plus 8 is going to give you 11. The first thing that we're going to have to do is see how much of each we have if there are a total of 77. So right now I have 11, and let's say I up that to 77, so how many do I have? So let's see how many cats I have first. We know we have 3 cats out of a total of 11, and we know we have a total of 77, but we don't know out of those 77 how many are cats. So we're going to set up this proportion. Total is always on the bottom, and part of that total is always on top. And the part that we're talking about are the cats. Then I'm going to cross multiply. So 11 times C is 11C. 3 times 77 is 231. Then I'm going to divide both sides by 11. And 231 divided by 11 is 21. So I have 21 cats. So now I need to find out how many dogs. Since I have 21 cats and I know I have a total of 77 animals, I'm going to subtract 77 minus 21 and get 56 dogs. Okay, we're not done yet though, because we need to see how many more cats I need. I have 21 right now. How many more if I was going to have a ratio of 1 cat to 2 dogs? That's what the question's asking. So I need to set up a second proportion. So we want to have the ratio 1 cat to 2 dogs. So we need to figure out if we have 56 dogs, how many cats. So I can cross multiply and I find out that there's 28 cats. Now, you could have just divided 56 by 2 and got 28. And that's how many cats I need. Cats we need to have that ratio of 1 to 2. So either way works, however you want to think about it works. But let's go back because they ask, how many more cats do we need? So we need 28. We only have 21. So 28 minus 21 is 7. So we need 7 more cats to make the ratio of cats to dogs 1 to 2. Okay, that was number 1. Let's go on to number 2. Number 2. A copy machine can copy A packets in B seconds. If each packet contains M pages, which expression shows the rate of copying in pages per second? Now, when we were going over this in our SAT session, a lot of students said, we have per second here. So seconds needs to go in the denominator. And so they looked at all of these choices and they found that choice D, which was B, and B is seconds here, B seconds, they noticed that's the only choice with B in the denominator, and they chose D, and D is correct. So you can go through and just say, hey, we know it needs to be seconds in the denominator. The variable for seconds is B. That's the one that only has B in the denominator. You could do that, choose to do that, or you could map it out where you label everything and you get the equation yourself. So we have rate is pages per second. We have A is packets and M is pages. So if we have 10 packets that had 5 pages, then we would have a total of 50 pages. That's how I got A times M, 10 times 5. So A times M, and then rate, seconds is in the denominator, seconds and seconds. But you didn't have to go through all of that if you did realize that seconds was going to be in the denominator, seconds was the variable B, and that was the only choice there with that variable in the denominator. Okay, so let's go to number 3. Number 3, if 1/3 x equals 5 times the quantity x minus y, what is 4x? What is the ratio of 4x to y? Now, when we were talking about this question, there are really a lot of different ways to do this. You could realize that we're going to have 4x over y. So you could choose the denominator. Let's say y is 14. Well, 4x is going to have to be 14 times 4. And so when we get 15, that is not 14 times 4. If we said that y is 7, so we said that y is 7, okay, well, this would have to be 4 times 7, which is 28. Oh, that is pretty close. So 30 and 28 is pretty close, so it might be B. Okay, we could say, all right, if y is 3, then this would have to be 4 times 3, so we're going to be getting an answer close to 12. 70 is not close to 12, so it's not C. And for this one, if it's 3, again, we'd have to do 4 times 3. That is definitely not. So without even doing anything with this first part of the problem, we could just use substitution and guess and check. If this denominator was y, the numerator would have to be 4 times it. So you could think about it or think through it like that. Now, I am going to show you the math behind it. If you like thinking about the question like that, that's absolutely fine. But I do want to show you the algebra behind it. So for number 3, I am going to use that first part. 1/3 x equals 5 times x minus y. We need 4x to y. So the first thing that I did is I simplified and solved. I multiplied both sides by 3. That got rid of the 3 here. So x equals 15 times the quantity x minus y. I wanted to get my x's on one side, so I subtracted 15x. And then I divided by negative 14, so I would solve for x. I choose to solve for x because this is the one we would need to multiply by 4. So let's multiply both by 4. So I multiplied 4x here, and I multiplied 4 here. Now be careful because you see this answer. It was one of our answers, but this is just one x. We need 4 of them. So be careful when you're doing this using the solving method. So I multiplied both sides by 4, and I got 60 over 4. I reduced to get 30y over 7, and that was our answer, was 30y. 30 over 7, sorry, 30 over 7. So this was our answer that we saw here, 30 over 7, which was our answer. So you could do it either way, if you wanted to do it the solving way, or if you wanted to think through it, either one works. Okay, let's go to number 4. Number 4, of the first 80 people entering a baseball game, 27 were children. At that rate, how many children would be expected to attend the game if 32,000 people attended? So right now we have first 80, so that's our total. And part of that are 27 children. We have another total, so let's say that 32,000 people show up. We want to know how many children. So you are going to set up a proportion here. And so we have 27 children out of a total of 80. What we have expected to go, I'm not sure how many children, but we expect 32,000 people. So I set up the proportion 27 over 80, part out of the total, C out of 32,000. I cross multiplied 80 times C, 27 times 32,000 is 864,000, pardon me. And then I divided both sides by 80, and I got 10,800 children. And you will see that's answer D. Okay, Number 5. Aaron's car engine will run for 30 minutes using a half a gallon of gas. Aaron spent $7.15 on gas that kept the engine running for 2 3/4 hours. What did he pay per gallon of gas? So we have what did he pay per gallon? So it's going to be what did he pay per gallon? And so I always like to set it up as per. All right, so if we're running it for 30 minutes, you're right. 60 minutes, if we run it for 60 minutes, I bet you we're going to get a gallon of gas out of that. So some of you might already say, hey, can we just divide $7.15 by 2 3/4 hours? But what is 2 3/4 hours? It's 2.75 hours. And you would be correct. You would come out with answer B, $2.60. That is correct. I am just going to run through it mathematically with first step, second step, because some people might need to see what my thinking is just a little bit more in detail. So here we go. So we know the car will run 30 minutes on a half a gallon. The total spend is $7.15. Total that we ran the car was 2 3/4 hours. We have to change our units to hours. So if the car will run 30 minutes on 0.5 gallons or half a gallon, 60 minutes, you're just doubling it, so times 2. So we did times 2 here, times 2 here. So 2 times 30 is 60, 2 times a half is 1 gallon. You could have just automatically known that. Absolutely fine. Again, I'm just showing you the math behind it. Number 2, let's find the cost per gallon. I can set up a proportion here. So I'm going to change 2 3/4 to 2.75. How I got that 0.75, you really divide this in the calculator. 3 divided by 4 is 0.75. That's how I got that 0.75. I cross multiplied. I divided both sides by 2.75. And I got 2.6, so cost is $2.60. However, here we have an or down here. You can just divide $7.15 by 275 and get 260. So you didn't have to go through all of that. I just showed you the proportion. Some people like to see the proportion. Or you can just divide because it is cost per gallon. Cost per gallon. Okay. Let's go to number 6. Terry randomly selected 44 classmates and asked them whether they preferred a 1950s theme for the school dance or a 1920s theme. Of the respondents, 18 said they preferred 1920s. There are 792 students at Terry's school. Based upon the results, how many would prefer 1950s? So again, this is when I see these types of problems, I really like to organize my information for what I have, and that's what I did here. So I first said, okay, we took a survey. Is it going to be 1950s or 1920s? We don't know how many people for 1950s. We know that for the 1920s, we have 18. We have a total of 44. So 44 minus 18 is 26. So we know 26 out of the 44 said the 1950s, okay? So that would be 26. So that's out of the 44. 26 out of the 44. So here's 1950s, 26, just like we found out here. Now, if we have a total of 792, we want to know how many wanted the 1950s. So we set up the proportion. X over a total of 792 equals 26 out of our total of 44. You cross multiply. 44x equals 20,592. Divide both sides by 44. And we get 468 voted for the 1950s. And I'm not sure. Okay, so this isn't a multiple choice one. And so that voted 1950s. So if we had 44 26 would have voted. If we had 792 a total, then 468 would have voted for the 1950s. So this is almost a two-part one where you first had to figure out that missing information based upon the total they gave you, and then setting up your proportion to find it out of that new total. So just be careful because they might give you a previous total and then a new total. I think that's what we're seeing along the way here. Okay, that's number 6. Let's go to number 7. We're halfway done, everybody. Students in the Marshall County School District were surveyed about their transportation to school and their average test grades. The results are shown in the table. We have average test score 70 or less all the way to 86 to 100. All right, we have they take a bus or a car to school, they walk, and we have a total here and total here. Okay, let's see what the question wants us to do. From the group of students surveyed, 50 students were randomly selected for a follow-up survey. Okay, so 50 more were randomly selected. Of those selected for the follow-up, approximately how many would you expect have an average test grade between 71 and 85? So we're looking here. Okay. And walk to school. And we're looking here. Okay, so I like to annotate like that because in a table there's so much information that you're given that we have to annotate to see what are we talking about, which information. So we know we're going to be talking about this information, that information. All right, so out of the 50, so we know we have an overall total of 4,018. So again, this feels like we have a new total, we have an old total, and then we have a new total. It feels like a proportion one to me. Again, I'm going to organize my information. So let's look to see. All right, so we have an average grade of 71 and 85 and walks to school. So the first thing that we want to find out from that table is how many overall have 71 to 85 average and walks to school. So we're talking about this number right here. Okay, that's from our table. So that's what we know. Okay. We also know the total in the survey is 4,018. So we need these two pieces of information to, yes, set up a proportion. Okay. So we have average grade and walks to school. We don't know. We know that we're having another randomly selected total of 50 students. So we want to know of those 50, how many have this average grade and walks to school. So let's use this information and this information to set up a proportion. So here's our proportion. 1654 divided by 4018, these two numbers, equals x divided by 50. So this was our x divided by 50. We're going to cross multiply 50 times, and then we're going to divide by 4018. Now, we have 20.5 equals x. We can't have 0.5 of a person, so let's round up to 21 students. And let's go back, and we see that that's answer B, 21 students. And if through any of these you want to go back and pause the video and see what I did, you're more than welcome to. All right, let's go into number 8. If the ratio of A to B is 1.2 to 5.4, find 3B when A is 47. Okay, so A to B is 1.2 to 5.4. So that's the first fraction I set up here, 1.2 to 5.4. So the first thing is let's find B. 1.2 to 5.4 equals 47 came because they gave it to us. A is 47. Okay, so first I found B. Cross multiplied, B is 211.5. Second thing, now we have to find 3 times that. So we have to find 3 times this. So 3 times 211.5 equals 634.5. And there you have it. Okay, number 9. Ooh, all right. We have a nice bar chart here. Let's just look at it first. It's given to us first. This says insect counts for 3 pesticide treatments. And we have colony A, colony B, and colony C here. Over here, we have number of insects that ranges from 0 insects all the way up to 160 insects. And I believe we're counting by 20s, 20, 40, 60, 80. Okay. Here are weeks after initial treatment. So 0 weeks after initial treatment. So that's the start. No time has passed. This 2 weeks after initial treatment, 4 weeks after initial treatment. And each of these represents a colony. All right. So I'm going to read this to you. 3 colonies of insects were treated with a different pesticide over an 8-week period to test the effectiveness of the 3 pesticides. Colonies A, B, and C were treated with pesticides A, B, and C respectively. Each pesticide was applied 2 weeks to one of the 3 colonies over the 8-week period. The bar graph above shows the insect count for each of the 3 colonies at 0, 2, 4, 6, and 8 weeks after the initial treatment. All right, what questions I want us to ask? Which of the following colonies showed a decrease in size every 2 weeks after the initial treatment with the pesticide? So we need to see it go down every 2 weeks after the initial treatment. So we're not going to look at week 0, everybody, because that is when they applied it. We're going to look at week 2 because we want to see what happens after. So that's a common mistake. So just take out 0 right now. We're just looking, we want to see after the 2 weeks after they initially applied it. So this was kind of like the start count of the insects. And so here we just have to be careful because let's just look at colony A. Let's look at these individually. So colony A is this first bar here. All right, so it started up here. Let's see if it decreased. It went down. Yes, it went down here, it went down here, and it went down here. So we say colony A definitely decreased every week. Colony B is this kind of dots. So that's the second colony right here, the one in the middle. Let's see if that decreased. So it went from here to here. Okay, that decreased. That decreased. And let's see, that decreased here too. Did it decrease here? Yep, it went down as well. Okay, perfect. Okay. And then colony C, you know what? Actually, we are, oh no, we got it. Colony C, every 2 weeks after the initial treatment. So C went down, went down, went down, went down. Yep. So all 3 decreased over that 3-week period. So 1, 2, and 3. Every 2 weeks after the initial treatment. Perfect. Ooh, no, we did this wrong. We did. I didn't want to look at 0. Hold on, let's back up a minute. Now this is where the learning comes in, correct? All right, let's just look. This is the start. So this would be 2 weeks after. So we do have to look at 0. I didn't think we had to look at 0. That is my mistake right there. See that? Sometimes math teachers make mistakes too. So this is when they put the pesticide on the plant is week 0. But then we waited and waited and waited. In 2 weeks, we see that, let's look at A again. Let's just do this one more time, but we're just taking into account this week. Let's just see the decrease went from here. Yes, it decreased, 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 decreased. So A did. All right, let's look up B again. Good practice, everybody. All right, B is this middle one. All right, it decreased, it decreased, it decreased, and it decreased. So B decreased. And then let's look at C. C is this last one. Okay, so at week 0, we were a little bit less than 60 insects. What happened? Yes, that increased and went all the way up. So I wonder, it might have liked the pesticide. Who knows? Some bugs do. So C did not. So the answer is 1 and 2 only. So you do have to look at that start. My apologies for that. So definitely look from week 0 to week 2 what happened, because it was after that initial treatment. Okay. let's move on. Getting my paper situated here. That was 9. Let's move on to 10. Okay. 10, we have another, we have the same bar graph. Okay. So same bar graph that we just had, different question. Same exact information here, weeks after treatment, number of insects. So let's get the whole problem. Of the following, which is the closest to the ratio of the total number of insects in all 3 colonies in week 8 to the total number of insects at the time of initial treatment? All right, so total number of insects in week 8 to the total number of insects of the initial treatment. So here's what we have to look at. Total number of insects week 8 to the total number at initial treatment. So we're going to look at the bar graph, total number of weeks in week 8. Here's week 8. And so we have to look at each one of these bars and we have to estimate. So if I look at this bar right here, I'm going to come over and it looks like about 19. This little bar looks like it's halfway between 0 and 20. This one right here looks like it's like halfway in between. I'm not going to do a very straight line, so it looks about 10. And then this tall bar looks about halfway between 40 and 60, so I'm going to call that 50. And so I'm going to add them together and I get about 79. You could round. I mean, it might not be exactly, 19, 10, and 50, so we're pretty close. Now I have to look at the total number at initial treatment. So initial treatment is week 0, remember. So it looks like this bar is at 80, this one's about 65, and this one is about 58. You see it's almost close to 60, so I'm going to call that 58. I'm going to add those together, and I'm going to get 203. And so let's set up our ratio, week 8 to the initial. So I have 79 to 203, which is 0.389. Okay, what is 0.389? Well, we could do this a couple different ways because this 0.389 is not on our answer key here. All right, so what could we do? We could estimate our answer to 80 over 200. So remember, it was 79 over 203. I got very particular about where my bars were. And if you reduce 80 over 200, you get 2 over 5, which is A. So you could do that. Or if you did divide this out, you could see which one of these is the closest to 0.389. So we could round this to 0.4. And so you could divide in a calculator. This is going to be equal to 2 divided by 5. So if you divided 2 divided by 5, or if you wanted to do 2 divided by 5 in a calculator, you are going to get these decimals. This is 1 divided by 4, 3 divided by 5, and 1 divided by 2. And so you can see which decimal was closest, and you still see that it is answer A. So either way you want to do it, you do have to come back to these whole numbers here. So I like rounding it and then reducing it, but some people might like dividing it out. So the answer is A. Okay, let's go to number 11. The ratio of men to women in a hiking club is 3 to 5. If there are a total of 32 men and women in the club, how many more men would make the ratio of men to women 1 to 1? This reminds me of the cats and dogs one. So let's organize our information and find out how many more we need, how many more women. So we have, how many more men, So we have 3 men and 5 women. So we have a total of 8 right now. We need to find how many men if the total was 32. So we're going to do 3 over 8 because that's men. We don't know how many out of a total of 32. So we set up a proportion. We cross multiply and divide, and we get M is 12. So there's 12 men here, so that's 12 if we had 32 total. So there are 20 women. Okay, so because we know the number of men was 12, and we have a total, if we take the total minus the men, this is how many women. Second, how many men if the ratio was 1 to 1? So we're going to take men as 1, woman as 1. We don't know how many men, but we know that there are 20 women. So they're going to have to be 20 men. Well, 1-to-1, you could have, or just known if there is 20 women, a 1-to-1, there definitely needs to be 20 men because they're the same. So either way you want to look at it, if you're just into proportions, you can go for that. All right, there are 12 men right now. That's what we found back up here, 12 men. How many do we need? We need 20. So how many more? We would need 12 minus 20 minus 12 is 8 more. So because it's 1-to-1, we could have just jumped from here to here and just subtracted 20 minus 12. Either way you want to think about it, there's many different ways to think about each one of these problems. I'm only showing you a couple of those ways, so if you have another way of thinking about it, that's absolutely fine. Okay, let's move on to number 12, and we are on our last 3 problems. Number 12, some randomly selected students from grades 7 and 8 were asked if they were in favor of a shorter lunch period if it resulted in a shorter school day. The results are presented in the table. We have yes and no, grade 7 and grade 8, and we have our totals. What fraction of those who voted no, were 7th graders? Voted no were 7th graders. So again, I'm telling myself, I'm going to have to look at the no grade 7. So I'm probably going to have to definitely look at no grade 7. And I mean, you can even connect these. In the problem, it tells you where to go. What fraction voted no were 7th graders? So first thing that we're going to have to do is look to see how many 7th graders voted no. And that was 30. We got that here. Perfect. Okay. And then we need to look at the total who voted no. Total who voted no. So it says, what fraction of those who voted no? This is how I knew to use this number right here. It says it in the problem. What fraction voted no? And so when I set this up, this is the total voted no. And this is the one no and grade 7. That was 30. So I divided out 30 over 40. I reduce it to 3/4. And I don't believe it was multiple choice, so you would write the fraction 3/4. Okay, number 13. Same table. Some randomly selected students from grades 7 and 8 were asked if they're in favor of the shorter lunch period. Here's the results. So we use the same table. What does this want us to do now? What fraction of 8th graders, okay, what fraction voted yes? What fraction of 8th graders voted yes? So let's see, what do we have to look? What fraction of grade 8 voted yes? All right, so we have voted yes. We got a total of 60. What are we going to use? You got it. We're going to use what fraction of 8th graders voted yes? Okay, so what fraction of 8th graders? Let's erase the 60 because it didn't say what fraction voted no. It said what fraction of 8th graders. So we know that, and I'm going to do this right on the paper right here. The fraction, what fraction of 8th graders? How many total 8th graders? 50. All right. How many of them voted yes? 40. And so to reduce this fraction, it's going to be 4/5. And that's it. What fraction? There we go. Okay. So it really is seeing what they want the fraction to be, what fraction of 8th graders, that's going to be your total. Like up here, what fraction voted no? Voted no is going to be your total. So you really have to look in the question what they want that denominator to be, what they want your total to be. And then you can go and see what fraction of your total voted yes or voted no. Okay. A runner in a 100-yard race finished 12.5 seconds in 12.5 seconds. What is the speed in miles per hour? This seems like just a simple one-step multiplication, but it's not because we need to change a couple different things. First, we have a 100-yard race, and they want us to change to miles. Then we have how long they finished in seconds, but they want us to change it in hours. So I'm going to take this step by step. This is a unit conversion one, and I'm going to do it in 3 steps. So first, we need to go from yards in seconds to miles per hour. So let's change yards to miles. So we have 100 yards in 12.5 seconds. We're not going to touch this yet. We're just going to multiply by 1 mile is 1,760 yards. Now, here's my trick for unit conversion. What you want to change is in the numerator, yards, it has to be in the denominator so they can cancel out. That's how you know to set up your problem. Let me say that one more time. We want to cancel yards out. Yards is in the numerator, which means when you multiply it, yards has to be in the denominator so we can cross those out. Miles takes over. So 100 yards times 1 is 100. 12.5 times 1,760 is 22,000 seconds. So we have 100 miles in 22,000 seconds. Now, let's change seconds to hours. Okay, we're not touching miles. So seconds is in the denominator. It has to be in the numerator. So we have 60 seconds in 1 minute. Seconds is in the denominator, has to be in the numerator. That's how you set it up so they cross out. Now, we have minutes, but we need to get to hours. We have minutes in the denominator. You're right. So minutes is going to be in the numerator, 60 minutes per 1 hour. And that's how we know how to set it up. Multiply across, and our last step is to divide. So we have 16.4 miles per 1 hour. And there is your unit conversion. I'm trying to get it all in the frame right here. Hopefully this helped. This has been session 2 of SAT strategy. Thank you.